Hi everyone, in this video we are going to look at 5 different systems and we're going to try to classify them as either a galvanic or an electrolytic cell. So hopefully this video won't be as long as some of the other practice videos have been. So let's start off with something very straightforward. So if we give you this, this equation and with this information, and that's all you have, so don't look at a textbook, don't Google anything, but just from this, would you predict for this system to be a galvanic or an electrolytic cell? Go. Alright, did you get an answer? Hopefully you did, but if you didn't, do not worry at all. This is kind of new territory for us, so don't freak out just quite yet. So the first thing that I personally look at when I'm trying to decide if something is galvanic, meaning spontaneous, or electrolytic, non-spontaneous, I automatically look at the energy. So right away what I see is that energy has to be added to the system in order for it to convert its reactants into products. So right away we could classify this as what's called an endothermic reaction. So if this is an endothermic reaction, what that is telling us is that this is not a naturally spontaneous process. It requires energy to go from reactants to products. So the only thing we could say about this is that this is definitely going to be an electrolytic cell. It's not going to happen naturally. It requires energy. So now, using that information, let's see if we can look at the second problem. Is this one galvanic or electrolytic? Alright, so you use the exact same thought process here. So you automatically look for the energy component. And so this time the energy component is written on the product side. So this is telling us that this is definitely an exothermic reaction. So something that happens naturally or spontaneously. Very, very easily we can take hydrogen gas and carbon monoxide and convert them into carbon dioxide and methane. It's super easy to go from reactants to products. So if it's an exothermic reaction, it's a spontaneous process, I would predict that this would be a galvanic cell. Okay, galvanic. All right, next one. What about this one? Go. All right, so this is very similar to questions 1 and 2, but there's a little bit of a flair added to it, or something a little tricky. So this time, instead of actually adding the 249 kilojoules directly into the equation, we've just provided the enthalpy of the reaction. So automatically, again, you look at the energy. What I see is this positive sign. So if we give you an enthalpy and something is positive, we know that that is an endothermic reaction. If we give you an enthalpy value that is negative, you know that it is an exothermic reaction. So we said in the previous examples, if it's endothermic, it's highly likely that it's going to be an electrolytic cell. If it's exothermic, it's highly likely that it's going to be a galvanic cell. Okay, so does that make sense? So if I gave you this same thing and put a negative term, you would obviously say, oh, exothermic, definitely galvanic. All right, let's try another one, but this is more of a picture that I clearly hired somebody to draw because it's so beautiful. Galvanic or electrolytic? What do you think? All right, did you get an answer? Hopefully you did, and the one thing you are doing is looking for a battery. Is there a battery? And I say absolutely not. I see a voltmeter, but a voltmeter is just measuring the difference in potential energy. It is not actually giving us energy. So if there's no battery, then this is definitely a galvanic cell. Straight and simple. Very, very easy. Let's look at another one. This one's a little bit prettier. Not much better though. Galvanic or electrolytic? All right, did you get an answer? Hopefully you did, because all you are doing is looking for a battery. So the only thing you want to figure out right now is there a battery? Is there an external source of power? If there's an external source of power, then this is a non-spontaneous process, meaning that the electrons are not naturally going to flow from the anode to the cathode. In the previous example, there was no battery, no external source of power. Very, very naturally or spontaneously, the electrons would flow from the anode to the cathode, definitely a galvanic cell. But now in this example, what I see right away is I see this really beautiful thing right here. And this is how nerds draw batteries, okay? So anytime you see something like that, so you see the big line, little line, big line, little line, and you see wires coming from it, that's indicating that there's a battery. A lot of times people want to indicate the charge as well, and they say the positive side's over here, negative side's over here. That's not super important for me. What I care about is that you understand that if you see a battery, so we're saying yes, there's a battery. If there's a battery, you know for sure 100% that this is an electrolytic cell. This is not a spontaneous process. The electrons are not going to flow from the anode to the cathode naturally. That's just not going to happen. All right, so we've gone through tons of different examples. Hopefully now you're starting to feel more comfortable with how you would identify galvanic versus electrolytic. But here's the big kicker question. At the very end of this, can you identify out of these 5 examples which one of these 5, or of all, there's maybe multiple answers, could be considered an electrochemical cell? Go. Did you get an answer? Hopefully you did, and the answer is all of them. If it's a galvanic cell or an electrolytic cell, by definition, it is considered to be an electrochemical cell. So if we were to draw out some kind of flow diagram or flow chart, we would have electrochemical cells at the top. We would be able to split them into half. And so if you're a galvanic cell over here, this is the spontaneous process. It happens naturally. Or you can have an electrolytic cell on this side. This is your non-spontaneous process. This does not occur naturally. But regardless, if you have a galvanic cell or if you have an electrolytic cell, you are always 100% talking about an electrochemical cell. That's the global term. It's what we say to describe all of this. It's an electro process that uses chemical energy, or the difference in chemical energy, okay? All right, hopefully that helps. I really want you to be able to see the difference between galvanic and electrolytic. It's something super important, especially if you continue on with chemistry. But to have a great week, take care of yourself and drink water.